And welcome. I'm covering right now homework 6, loops, C programming. It's ELET 2201, as you can see. We had 6 problems. I'm going to go over a couple of them especially. We'll go over all of them, but a lot of them especially, like, because, for instance, 1 and 4, they're basically one-time throughs. So once you run them, they're basically done. But the other ones, such as 2 or 3, 5 and 6, well, 6 is actually one-time through, but it's got a lot of values in there, and I just want to go over it briefly. But the 2, 3, and 5, they can have multiple run-throughs, so I'm going to run them a couple times to show that they work fully. We'll go over here. This is NetBeans IDE, and it works really good. I also downloaded Cygwin because it doesn't come with a debugger. That's the debugger right there, and I like it. It's all run on this one screen, and NetBeans is extremely intuitive, much more so than Microsoft's Visual Studios. It'll fill in blanks and stuff for you, and also if you have, it's also a lot more, how do I say, adaptive to errors. It understands your errors a lot better, I guess is what I'm getting at. First one though is just basically one through, so it's going to build there. You see build, and then come down here and it'll show it running through all of its build steps. And then it builds, it'll run it. You see you have 2 tabs there. Those tabs, you can build those up as much as you want, so you can sit there and run a few programs and look at the different results and stuff. So you can clearly see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Basically did what it was supposed to. So that's good stuff. Now we're going to go to 2. So this one up here. This is also very easy to switch. Go down here, set to main project. You're ready to run it. I already had it open in a tab up here, but this is the C programming code for it. After that, this one is summation of integers. So you want to run it real quick. It's going to build down here. Now it's done. Now it wants number of integers to be summed, so we'll put in 4. That's 4 there. Now you're going to type in one at a time the integers you want some. So we'll say 68, 55, 40, and feeling spunky, -3. So it sums them up. That is 160. I'll let you pull out your calculator and see if that's right. I'm pretty confident it is. It hasn't messed up yet. So move on to number 3. I could run that a few more times, but it's pointless. I've ran it about 10 or 15 or so now, and it works good. Set it to main project. Easy as pie. We'll click over here on the code just to let you see it. Get it all highlighted. Alright, and that's the code for this. This is basically picking the least integer. I just had the first one sets z equal to xx, basically whatever comes up when this, I'm sorry. No, that's right. Yeah, it sets it to there, and then right here, after x becomes 1, so basically when it goes through the loop once, it's going to use that. Then every time after that, it's going to use this, and if z is less than xx, which is what you're inputting, it's gonna set that equal to that. Basically, it's gonna work real good because it's gonna, yeah, yep. So we'll see you run that and see how it works. Build. That's gonna go away. It's gonna run through its steps. Alright, now it's ready for values. Enter how many values you have. So let's say you got 4 numbers. We'll say -3, enter 5, enter 15, enter, and negative. Make sure I hit that right. -7. So obvious choice should be -7. Right there, got -7. So good deal. That one works really well too. The next one was number 4. Set that to main project. Pull the code up, highlight it. So this is number 4. This one is one time through. Basically, run it. It'll sum up from 2 to 30 evens. It's gonna build. Gonna run. It should be 240, and it is. Good stuff. There's the code for that. Worked good. Now we're gonna go on to number 5. Number 5 was factorials. Set it to main up there. Main project. Click the code on. Run it. Okay, it's gonna be running. And there's the building. Alright, number to be factorialized. I'll put in 6. Enter 720. And that's correct. The only thing about this is I actually have it there. 64-bit computer can only run in this world is 2 to the 63 minus 1 because I'm using both negative and positive numbers. If I was just using positive, it would be 2 to the 64th minus 1. But I'm doing positive and negative, so but either it doesn't really matter whichever one you use. 20 is greater than 2 to the 64th. So basically, this will only work for numbers 1, 2 through 19. Anything after that is too big for the IDE to understand. Basically, goes outside of its limits. But yeah, that was a pretty cool program. Still to write. The last one was my favorite by far. This program I spent all weekend messing with it. I have a couple loops in there. I did some research online, but I can guarantee that this is all me. I found some stuff online that I liked, and I found my own way to duplicate it in. I didn't do any outside functions. Basically, this thing, what it does is it's coming through here. We print actually inside of C programming. This D right here is just a number. That's just a decimal number, X. This %X represents a hexadecimal number. So if I imply X into that, it will go ahead and give me the hexadecimal value. And %O is the same thing for octal, but for there. So then, next one, we come down, and I just put a big blank space just to set out here for the binary. And this loop right here does the binary. So basically, it just prints it out. This form right here, this will get you the binary form, but if you don't put in this for loop right here and make it reverse it, it'll come out backwards. I'll show you what I mean in a second by that. You'll have to read it from right to left instead of left to right if you don't put that in. That is actually what took me the most amount of time to get that binary to print out right. We'll run it right there. It's building. All right, and it goes all the way through. Number one. Got a successful run, 256, 1000000. Should be 9-bit, and it is. But we will come back up here to the top and show you what I mean. It actually prints all 9 bits every time. That's just how I had to set it up to get it to work right. But basically what I was saying is, like, if I didn't do this, I would leave out all these zeros, and that would be 1, it'd be right. This one right here, instead of 1 0, it would be 0 1. You'd have to read it this way instead of this way. But I went back and set it up to where it always showed 9-bit values, seeing as I had to go up to 256, which is a 9-bit number, or would be 12-bit if we're going base or 4-bit increments. But it took 9 bits to do it because, right, if we go all the way down, see it printed them all the way down, all the way up to 11111, and then finally over 256. Because 8-bit, all ones is 255. So. Yeah, that's pretty much how it worked out. It was pretty good. This one was really neat. I'd like to see if anybody else actually got it to work and work fully. And I'll be finding that out tomorrow. But, yeah, thanks, Steve.